Thinking back,
Oh, crap. Can you get it back? We just lost you.
hi, I'm so sorry I joined again. I somehow exited the meeting by mistake.
We can just start over if you want, or we
Yeah,
can just
let
carry on.
me,
It goes either way. We've barely started, so
I will just get my slides back up here and get going. To do in the other order, I guess I got to share my screen first. Okay. All right, well, thank you everyone so much for having me. Really thrilled to be speaking to this class. I think in a lot of ways, I was looking through the syllabus for this course after Dirk invited me and was really wowed by and really envious, honestly, of everything you all are getting to learn, because I think it's kind of like definitely a part of my formal education that was missing. And a lot of, honestly, like the early years of my career, I think I was trying to like piece together a lot of these same lessons from trial and error. But I think a couple of things that I wanted to talk about tonight that I thought seemed relevant to the coursework is how I've really used a lot of the tools that you're learning about in my career to build a wide range of data tools in R, both to help make my own work more efficient and fuel the work of other people. But first, I'll just give a very short background on myself. As Dirk said, my name is Emily. I've worked at Capital One for about the past 5.5 years, starting out as an analyst doing your really traditional credit risk type problems. If you flip open an intro stats book and see your very traditional credit risk default models, I actually spend time thinking about those sorts of things in the real world. But what I've been working on really the past 2 years is building an inner source community in Capital One and bringing a lot of the ways that we think about developing good practices and open source tools to how analysis and internal tool development works inside the company. And if that sounds a bit mysterious, I'll definitely be talking more about that throughout the evening. Before that, I studied math and stats at UNC Chapel Hill. And after that, currently outside of Capital One, I definitely have a lot of very statistical and technical driven hobbies, spend a lot of time on RStats Twitter, blogging on my website, and working with both rOpenSci and CRC Press, as Dirk mentioned. So just to give a slightly better idea of what I am and who I do on a day-to-day basis, I currently lead a team that builds out an analytical infrastructure at Capital One, and we really deliver 3 main types of products. First, we do a lot of work on designing really high quality and intuitive data sources that fuel analysis. Secondly, we build internal R packages that help analysts more easily build models, conduct analyses for common tasks like customer lifetime value modeling. And we also do a lot of work building an internal community of practice for others that want to get involved in treating analysis a little bit more like a software engineering discipline with a lot of the tools, once again, that you're learning about in this course. And the way that I started out on this journey was really kind of a grand accident in a way. I never really intended to think of myself as a developer or a tool builder. I was just somebody that wanted to do my own work, do my own analysis in the best way possible. But over time, I sort of fell into this pattern where I started building small little side of desk tools and R packages and chunks of R code to meet my own needs for my own projects, started sharing them with other analysts and other colleagues at Capital One. And over time, noticing that the commonality of our needs was so similar that there was really a benefit to treating those more like open source tools with a lot of knowledge sharing, contribution from the community, etc. So I won't spend much more time talking about myself because believe me, I much would rather talk about R, which is what we're going to spend most of the time doing. I did, however, want to just say one or two more words about how I got to where I am in my career, because as I think you're all thinking probably about making your own career decisions, it can be helpful. And I think the sort of funny thing is for me, my career path was actually predicated on some very poor assumptions of what I would be doing at any given step. I started out really loving mathematics, so that motivated me to study statistics at college because I wanted to apply that same rigor and have that same certainty when thinking about human problems. But probably as all know, stats turns out to have a lot of subjectivity, a lot of decisions you have to make, and is arguably more art than science. But that's okay. I still loved all the the methods I was learning, really loved statistics. So I decided to go into data science and analytics professionally, and kind of pictured myself using this rich statistical toolkit that I'd learned in college to make decisions and find insights. But then I found that actually a lot of the impediments in the real world are in having poor software, poor tools, bad processes, bad practices, and bad data. And over time, I think I've gravitated more and more towards solving a lot of those structural problems, which is why I'm so passionate and excited to talk about things like workflows and tools. So kind of despite all those bad assumptions, I think kind of the path I took, really, I took a kind of like few things away from each experience that were really, really formative to what I'm going to spend almost all of the rest of this talk talking about, which is building better tools and workflows and processes with R. For math, I think I really took away the need to have a lot of rigor and precision when defining abstractions, and then the power of being able to apply those abstractions in multiple circumstances, which is really important when we talk about building R packages. From stats, of course, had a great tool bag of methods, and because in college I was not very good at programming, developed a really like quite a soapbox and a lot of frustration around bad workflows and an appetite to build good ones. And finally, in industry, I've gotten to use a lot of like new technologies and figure out how to share the idea of all these technical things that I'm passionate about with other people. So what the main things that I want to talk about today are kind of four main, I think, key realizations that have really shaped the early years of my career. First, that RMarkdown was a gateway to doing incredible things, producing great results, and developing more powerful tools. And that using good workflows with it could provide really a transformative amount of leverage. Secondly, as I then dipped my toe in the water of data tools, I started thinking about how packages were more than something that could just be functions on CRAN, and something that I could build and I could share with others, and that in the organizational context, packages can play many different roles. And these are really the four main themes that I want to hit on as I talk with you all tonight in sort of like two main subsections. First, I want to talk about our Markdown-driven development and how I moved over time from thinking of our Markdowns as one-time kind of throwaway notebooks to the makings of sustainable data products. And secondly, then I'll want to talk about how I use some of these data products and turn some of my one-time analyses into R packages that I've used within an organizational context. So first, let's talk about our Markdown. So I first started, I really fell in love with our Markdown early in my career at Capital One because of just its amazing versatility in literate programming, combining code and pieces of narrative to shape my analysis and be able to reproduce it, rerun it when I got new data or was requested to make changes. And of course, beyond that, it empowered me to make an incredibly wide range of outputs beyond static documents, from things like dashboards, documentation, websites, slides, and more. But something that I realized over time as I was working with our Markdown was that it was more than just a reporting tool. But as I kind of went through that process of literate programming, I was actually designing somewhere in this R Markdown, there was this latent tool that was kind of custom fit to answer the question that I'd set out to ask. And if I think about it, this implicit tool already had a lot of the core components that I'd need to make an explicit real-world tool. Of course, if you have a working RMarkdown, you've already done a lot of the hard work of curating related and important libraries in the R community and developing working and hopefully well-tested code to answer your question. But beyond that, you've also handled some gnarly design decisions, possibly without even realizing it. You've had to really think about what you as an analyst need from the work you're doing. You've had to develop kind of a good cohesive workflow for how you string all those parts of your code together. And with the analysis that you've written your Markdown to accomplish, you probably found a complete and compelling workflow, an example of what your tool would be capable of solving. So with this kind of realization, over time, almost without knowing it, I started edging towards making my implicit tool into an explicit one. And after I'd done this a few times, I began to realize that this thing that I was kind of just doing accidentally really had kind of a process. And that's the process that I've started to think of as our Markdown driven development, which is what I want to talk about tonight. And I really define that as 5 main steps that can be used to turn any R Markdown that you wrote for one-time use into some sort of a sustainable data product that you can reuse or you can share with others more readily. And I do want to call out that this has multiple endpoints, and you can always take the right exit ramp for your type of problem. You can end up with a really well-engineered single file R Markdown, a project, or even, as we'll see, a package. But just because this is a spectrum, it doesn't mean one is better than another. One necessarily has a better UI than another or is higher or lower quality. But simply different outcomes can be more or less suited to different circumstances, which is also something we'll talk about. So the first step to how I approach our Markdown-driven development is simply removing all of the troublesome components that probably shouldn't be in your R Markdown at all, like hard-coded variables, passwords, local file paths, and unused chunks. So first, I like to be sure that I'm using parameters instead of hard-coded variables. In any sort of industry context, inevitably you'll have to build some sort of report to either monitor a model, check your business KPIs, do some sort of task on a regular basis, which probably always means you have something sort of like a date filter. Of course, if we just have these sprinkled through our code, the next time I run this, I might not remember to change my filters or to change them consistently in all of the places they might appear in my document. But instead, by raising those up to an R Markdown header, I can almost turn my whole R Markdown document into one mega function, and I can easily change the parts that matter and have confidence that those changes have been consistently applied throughout. That same trick of using parameters is really also a useful way to remove plain text passwords that you might have put into your R Markdown for something like connecting to a database. And if you're using RStudio, you can you can just put in your credentials then on the fly using their knit with parameters option in their IDE, which opens up a nice safe way for you to type your password in ephemerally where it doesn't get shared anywhere. But of course, there are also other really good options like keychains or environment variables. The next thing I aim to remove is removing any local file paths, since those will break if I potentially move the file where my project or my R Markdown exists on my computer. You've probably seen that relative paths are more resilient than global file paths, but sometimes these can even break if I have a colleague try to run my R Markdown on a different operating system with different formats. So something like the here package can generate even more dynamic and resilient working directories across operating systems. And overall, I think this first step is pretty easy. We're just doing some house cleaning, but I will say removing unused chunks is the hardest. I often, by the end of a project, have code that I really thought was going to work and lead some really interesting conclusion, but that ultimately didn't end up being part of the story that I want to tell with my data. And of course, any side work you do is probably good and useful to save somewhere for some future purpose. but it's good to not let your Markdown be that junk drawer for experiments that you don't want to talk about in the more literate programming aspect. So good to clean those up as well. So the next step that I usually take when refactoring an Markdown to make it a more reusable data tool is rearranging components. Markdown, again, is great as a literate programming tool because it captures our thought processes, but our thought processes are naturally nonlinear, and unfortunately, our Markdowns capture that nonlinearity and can have a lot of odd pieces of code sprinkled around. What I tend to recommend is bringing all infrastructure and computing chunks to the very top of my document and more of the narrative and communication chunks to the bottom. And this has multiple benefits. First, bringing those kind of like heavy lifting chunks to the top can help make all my dependencies more clear because I hopefully have a single chunk where I'm doing things like loading my packages, a single chunk where I'm doing things like reading in my data, etc. And it also increases the chance that if anything in my code is going to fail, it fails early during this more heavy lifting computation instead of in the last mile of running Markdown, which can definitely be pretty frustrating. This also has the benefit of grouping more like pieces of code together, which increases the likelihood of my noticing repeated code. And while I'm doing this step, this is a great time to actually make some small structural changes in your Markdown that really give your code file the sense of having a user interface. And specifically what I mean by this is going ahead and naming my chunks. So if you're using RStudio, you have this nice table of contents where you can easily jump between chunks at a click of a button, and adding comments into my Markdown delineated by this quadruple dash. And what that dash does is it adds an entry into that table of contents that we talked about, so to help me move between sections of code super easily. So now that we have this very well-organized Markdown, stripped of any unnecessary content, the next thing I start to do is look for the repetition in some of the computations and visualization and wrangling I'm doing, and turn that raw code into functions that I can define once and call multiple times. I'm sure you all have probably seen functions in your course and understand a lot of the benefits, but I want to go through one brief example because I think there are even more benefits than meets the eye. Before someone might do this step, you might have a lot of repeated code in your Markdown, and eyeballing this side on the left side at a glance, we can pretty easily discern that we're making a lot of GG plots, but in all that gnarly code, it may not be obvious which element of the plot is different in every single graph. Instead, if in our Markdown, we take one chunk to define a function and then call it multiple times, there's both the computational benefits of being consistent and being able to change this function in one place and have it apply everywhere. But even more than that, there are literate programming benefits because I can super easily eyeball this and be like, oh yeah, so the thing that's different in these three functions and these three plots is that this one y variable is changing. And secondly, something else I like to do at this step of refactoring my Markdown is be sure that any of those functions I'm defining and using within my Markdown, I'm adding in our Oxygen 2 skeletons. This is something that you can easily do, particularly with a shortcut in RStudio, to define all of the key pieces of metadata about a function. And should you go on to make a package, this is exactly the sort of documentation you will need to automatically generate documentation. And because of that, it can actually be a very familiar format for our users reading your raw code to immediately recognize what those comments are telling you and have more visibility into what your code's doing. Something else I do at this step when I'm removing functions, since we're getting pretty close to the total amount of code that we want in our piece, is relying on some automated tools to get a free quality boost. Some tools that you might consider are linters, which analyze code and provide improvements to you, stylers, which can automatically reformat code based on built-in style guides, and packages that do other things like spell check just to help you catch mistakes. And if you haven't used linter before, I show an example of the output what output from that might look like on the right-hand side, telling you very prescriptive line numbers and suggestions of things that might change in your code. I personally always prefer linters to stylers because I prefer to get that feedback, think about things, and actually learn for the future better ways to format my code instead of just letting something else move my code around in an automated fashion. So with these first 3 steps, I would say we have a really robust standalone RMarkdown. And sometimes that's actually a great place to end the story. You have a very portable piece of code that if for some reason you can't store it in a formal version controlled repository, it's still very portable and easy to compare, easy to share, and easy to refresh with a single push of a button. But there are some downsides that might make us want to go a little bit further. First, single file RMarkdowns can be sort of lengthy, monolithic, and intimidating. They ask RMarkdown to kind of play the role of a job scheduler and do a lot more work than is necessarily necessary. And they may enable some anti-patterns, like not saving intermediate artifacts. So if those seem problematic for the size and scale of the problem that we're working on, the next thing I like to do is break apart the individual pieces of an RMarkdown and turn it more into our project instead of a single file. And the most important part, in my opinion, of moving to project is using some sort of standardized file structure that you have consistent between different projects. That way, if you're looking for some visualization function you wrote, you automatically know where within your vast repository you want to start searching. And similarly, if you're working with collaborators, it's a really nice latent form of documentation where you don't have to write a lot in the README explaining where to find different files, but they can just automatically know by glancing at your folder structure. So some of the choices I tend to make in this vein are saving the RMarkdown as a whole to an analysis folder because it is that final report that I care about, but starting to move my function definitions out in some sort of a scripts function, maybe even some of those preliminary data loading and data wrangling out to the scripts function. If I have raw data that's read only, I never want to touch it, I never want to modify it, I'll save that in the data folder. But any sort of intermediate data outputs that I make along the way in my Markdown, I might save to the outputs folder, etc. And then after I've split all that stuff up, I can polish my Markdown by referencing those things to pull them back in. For example, using the source function to read in a function that I've defined in a separate file, instead of having that function definition in the same folder. A lot of benefits here in terms of separate version control. So if I want to make one tiny commit that only affects this visualization function, the diff of that will be very clean. It'll be very obvious that I only changed one thing. Similarly, if I want to share just one function with a coworker on another project, it's much easier to do that now that it's all broken into pieces. And a secondary benefit that I find of the project structure is eliminating dependencies between parts of your code. When we have that single file RMarkdown, suppose you find one typo in your whole document. To rerun that, you probably have to go hit the database again, let it run through all your models, all your data wrangling. Could take a really long time to re-render that whole document just to fix this silly typo. But instead, with this fragmented project structure and saving our intermediate outputs, we're able to rewind and only do make incremental changes to the single part of a Markdown or project that requires those changes to be made for a much more lean and efficient workflow. And honestly, I think projects are oftentimes where I stop my personal projects when I'm trying to answer some sort of business problem. Some of the benefits of them are that they're very flexible to help us extract and share small portions of functionality, but they preserve a lot of the specific domain-specific context of the problem I was trying to solve when I was working in that RMarkdown. Of course, some of the downsides are the line between what's general purpose code and what's analysis specific code can still be a little bit murky, and they can't make full use of some of R's really, really great developer tools. So if you're trying to build something really robust that can be used across a super wide variety of circumstances, that's when you might consider turning your whole RMarkdown project into a package. And at first, if you've never built a package before, that may seem kind of scary and intimidating. I know that's how it first felt to me. But the actual hidden secret of our packages and the beauty of making them is there's really nothing more complicated about writing them than simply saving your artifacts in the right places, which is something that we've already spent a lot of time talking about tonight. And similar to how we walked through what the structure looks like of a typical analysis repository, we can think a lot about, or we can similarly move pieces of our Markdown into something that could be more of a draft package. Our code that defines functions lives in the R folder. Example data sets that you can use can live in a couple of places, one being the data folder. Your R Markdown itself or some minimized version of it could serve both as a template that users of your package can access, or as a vignette that simply describes at a high level what your package aims to do. And we can automatically generate the documentation folder from some of those code comments that we talked about previously. One of the only main components of a package that we haven't already discussed is unit tests. But honestly, for any kind of important project that you're working on developing, you should probably be thinking about adding unit tests to your workflow, whether or not you're building a package. So arguably, there's not really that much of an incremental left there either. And finally, I'll just call out for those that have started to, I think, embrace the wide world of our packages, it should come as no surprise that there are many great helper packages to assist in this migration, such as Use This, which is a great utility for helping make sure you save all the components of your R package in the right location. DevTools, which can generate the documentation files that we talked about previously. Numerous packages for testing like TinyTest or TestStat. And PackageDown, which creates the nice, really user-friendly and aesthetic package websites that you may have encountered in some of the packages that you're already using. So just to round out the comparison, packages are a great mechanism to formally distribute a package at scale, like on CRAN, or internally through CRAN-like repositories, or even on GitHub. And they also serve as a familiar format for others to learn and use and access. But I think there is also still a trade-off of what makes the most sense for the work you're doing. And I'm definitely not a purist that absolutely everything should end up as a package. If, for example, you're building that recurring report that we talked about at the beginning, by building a package, you might have gone too far and broken all of the useful pieces and up and distributed them around when you're just asking someone to simply piece them back together in the exact same way that you'd all had initially. So again, I think from like any of these three options can be really great and robust data products that can come from using our Markdown. It just really depends if you're more interested in solving the instance level problem of enabling someone to reproduce your exact same work again, or the generic class of helping people solve problems similar to yours. But no matter what path you choose, you applying an R Markdown driven development approach and applying some good workflows and practices to your R Markdown writing can help you develop a really empathetic and really robust data product. So that's really honestly a framework that I worked out in the abstract only after I'd incidentally applied it many, many times in my own work at Capital One, and created my first kind of few packages internally that had gotten a good bit of traction. So the second thing that I thought you might be interested in hearing about tonight is what kind of packages I was building when I was using our Markdown driven development, and how and kind of what our packages can do besides shipping out statistics code methods, which I know are like the main way I'd encountered them when I was in school. So when I think about packages, first, I want to think a little bit about you and what your first step will be after you graduate from UIUC. So presumably all of you will go, like wherever you go next, you will have some first day in some lab or some office. And there'll be a lot that you need to know: how to access data, what the right problems are to be asking and answering, where to find tribal knowledge, how to build up your intuition, and more cultural things like how to communicate with your teams, what meetings to go to, etc. Fortunately for all of us, when we only have to go through that awkward first day at work one time. But the packages we use, the open source packages we use, almost every day is like their first day at work because they can't preserve our business specific context. And that, to me, that's really the premise that got me really interested in internal package development. Open source packages really thrive by achieving that really, really high level of abstraction where they can solve my problem and they can just as easily solve someone else's problem halfway around the world who works in a completely different industry. But with internal packages, I found there was a lot of benefit into really being able to dig a mile deep into my company's own specific problems and provide very narrow solutions. And while the problems that I'm aiming to solve with internal packages are a lot more narrowly specified, sometimes internal packages can also be a lot more broad by encapturing many, many steps of the workflow. For example, if you think back to our Markdown-driven development, if I was writing an open source package, I wouldn't presume to tell every single other person in the world the one way they should store their password. But maybe I would presume to tell everyone at my own company that. So this kind of concept was what motivated me to start building internal R packages. And overall, I think I've found there's a lot of use in developing three main types. First, I tend to think of utility packages that help connect to company-specific resources like databases. I also work a lot with analysis packages that help capture that tribal knowledge and provide a curated workflow for modeling a similar class of problems. Again, you can imagine a credit card company at Capital One. There are many different teams focused on modeling customer lifetime value for different credit card products, but there's no reason they couldn't all draw from a standardized toolkit to do that. And thirdly, we have developer tools that can mean everything from trying to standardize workflows with things like Git hooks and linters to more fun, small things like standardizing a ggplot theme that allows you to use a company-specific color palette. So, but to make this more concrete, I thought it'd be helpful to walk through a few examples of the specific roles that I let these functions play, or packages play, because I do tend to think of these packages in my org as being in some ways teammates. And I think the deeper your knowledge is, the more easily you can make kind of tiny tweaks in the way you develop functions and in the way you develop packages that massively change the design. And I've really enjoyed kind of exploring this interchange between development choices and design choices. So first, let's consider what would it mean for a package to be like an IT guy. IT people are great at handling quirks of infrastructure and pushing good practices that users maybe don't know that they're required to use. And I think when I think about internal packages serving similar function, I think about providing utility functions, making it a very opinionated design choices, and providing helpful error messages. So as an example of this, we can consider a very basic function that helps a user connect to an enterprise database. It might collect their username and password and hardcode things like the port, the server, things that users shouldn't have to type every single time they want to connect. But of course, ideally, as we talked about in the last section, we really don't want users hard coding our password. And if I was writing an open source package, I'd probably want to provide these parameters, not presume, delegate the ability to make the right design choice to users. But in an enterprise setting, we can get a little more prescriptive and require users to do something like save their password to certain environment variables and access those only with the function. Similarly, we can that's only very useful if users actually know that's what they're supposed to do. There's nothing worse than getting a cryptic error message like DB user not found and not knowing what that means. So we can provide very specific error messages explaining to them what they need to do to get that utility working right. And finally, there may be other problems that your system personally encounters. So for example, at my company, we often have to use special characters in our password that don't always get translated right when sending HTTP requests. So we can encode passwords. We could provide another error message that would ask users to set their password to be a certain format, or we could just solve that for them implicitly. So the utilities class of functions just really, really helps things be smooth, work a little bit more automatically for a better user experience. Another use case I think about for internal packages is thinking of them almost like a junior analyst, where they perform work and attempt to make semi-reasonable assumptions, but they're very, very flexible. So I can coach them, use them to explore many different options, and be transparent enough so that I always understand what they're doing and why. I definitely, both in my colleagues and in the art packages I design, really, really try to avoid black boxes because it can be really intimidating to not know the details of what's going on. In some ways, I try to mirror this when I'm building internal packages is through default arguments, reserved keywords, and the R ellipsis. So just as an example for this, I might have an R package with a function that makes it like simple line graph that plots different cohorts of customers over time. Takes in the x-axis, the y-axis, the grouping variable, etc. But suppose I know what I think the x-axis that myself and all my coworkers will want to use 98% of the time. My first instinct, if I think back to the IT example, might be to hard code that variable inside the function. However, if I go that far, I've sort of limited the ability of this function to be used for any other use case in the world. Even if I think this is what users will want 90% of the time, I've essentially eliminated this function from having any possible utility the other 10. So instead, what we can do in R is use default arguments that provide the most likely option for different variables, and automatically will plug these in unless the user overrides them. And because it's in the function signature, that will be very readily apparent in the function documentation. And yet at the same time, users can super easily override this should they want to change these variables. And often I like to, in the industry setting, go one step further and define a set of reserved keywords of variables that I think users will often want to use in their analysis based on how our data is named and shaped in our company's database, and recommend that users shape their data similarly. And this can also have some nice cultural benefits of influencing people on many different teams to structure and shape their data in similar ways. Finally, whenever I can, both I as a colleague and I as a package developer like to try to collect feedback from the people I'm working with and help them be sure that they're really enabling their goals. And in the package sense, one way I like to do this is using the ellipsis. This allows you to pass arbitrary arguments into other parts of your R code that are user collected and not predefined by me as the developer. So for example, if someone wanted to specify a certain variable to color by and a certain variable as their line type, they can just go ahead and pass those into the function, even though I as the developer didn't know about them, and the function can automatically accommodate them by putting that into the aesthetics argument of our geom line. The third use case that I found for internal packages that I think is a little more unique and a little more different than what you see in external packages is actually acting not just like a coworker, but like a tech lead or like a principal investigator, and embedding a lot of institutional knowledge in one single place. Often I think external packages really err on the side of being agnostic to how people are using them, what they're doing, don't want to tell them right and wrong choices that might be super specific. But actually in the internal setting, it's often really hard to find people that have done similar work to you a few years back. But packages can be an interesting vehicle to deliver really important context in the right place at the right time through a number of different dimensions. And specifically to what I'll call lesser known features packages that I like to use to do this are vignettes and templates. So I suspect many of you in your current R use have seen vignettes as a common part of package documentation that really just helps kind of onboard and introduce packages, key features, and maybe set up instructions. Or in the case of some really statistically heavy packages like the survival package, they may include more journal type articles that explain the methods that they implement. But I've actually found vignettes are a really intriguing way to meet a wider variety of needs in the enterprise setting. For example, sometimes I use them to embed knowledge about a conceptual overview of the problem, key questions that I think ought to be asked along the way at every step, and gotchas to watch out for, and process documentation that could even include what other teams or processes or systems are involved in getting approval to do certain things, or you put the outcome of the model or whatever the package builds into production. Secondly, packages can also provide a technical overview, more like a traditional vignette, and explain different alternative methods the package implements and compare certain specific business use cases of when some might be better or worse. Finally, I think the most personal part of internal package vignettes is they can also include both lessons learned and discussions of past examples of successful or even unsuccessful use of the package, just to give that same sort of tribal knowledge that you get by talking to a coworker, an experienced colleague at the desk. And of course, we can expand the reach of these resources by automatically building something like a package website with a package like Markdown, and being able to display all of that excellent documentation we wrote on a website. So even some colleagues that don't strictly use our specific tools can still benefit from that shared context. And this is great because unlike a normal colleague, your package colleague's calendar is always clear to answer those questions and provide their input. The second piece of packages actually being more of a leader and a coach is thinking about embedding templates in your R package, which is something I definitely do a lot for my more analytically focused packages. This is something that you may or may not have already encountered on your own, but essentially many R packages can include templates that will open in any IDE like RStudio and provide kind of some sort of a framework. This is often used for packages like Flux Dashboard and many of the RMarkdown packages to help you understand a lot of the structural syntax that will ultimately shape how your content's displayed. But I've actually found a couple of other different types of use cases for templates when building internal analytical tools. And some of those can be both process walkthroughs that kind of coach people through doing some interactive analysis in an RMarkdown. For example, interactive data cleaning that provides iterative user inputs, giving them pre-populated chunks of RMarkdown code, and using the narrative to narrate things they should be thinking about when they consume the results. Alternatively, I've also used templates as analysis outlines, which can help kind of bootstrap users creating their own reporting, model white papers, whatever they need to do, by just having some boilerplate code already in place for them as a starting point. Finally, and this is a slightly more RStudio specific thing, but you can also embed a project template in your package as opposed to just a file template. And I often use this to ship that same sort of really opinionated file structure that I've talked about earlier in the RMarkdown section of this talk. So finally, and I know I'm about at time here, and be assured this is the last section. The last job that I find internal R packages very successful at doing is helping us, or is figuring out, sorry. The other really interesting benefit of internal R packages is the way they can interact with each other. In the open source world, if I write an R package, I don't exert any control over the other R packages out in the universe. But with internal packages, we can do some sort of interesting things by being really explicit about the interplay between them, specifically thinking about naming, dependencies, and testing. For naming, I like to try to use a super consistent API across all of our internal packages. So the knowledge someone acquires from using one package, such as the fact that maybe every single biz function returns a ggplot, can automatically be transferred from one package to the next. Secondly, I think it's really on the more kind of technical side with internal packages, you can really be a lot more intentional about your dependency structure. Often if I'm writing package A, I might have to depend on some other package, or if I'm writing package B, I might have to depend on some other package A that has some function of interest. But dependencies can always be a little bit scary, because if you depend on a poorly maintained package, something in your package might break. And the analog with internal tools is that if a package is mostly exists for a business need that goes away, that package may sort of cease to exist. But instead, there are a couple of different options that we can use when designing internal packages, of either promoting a clean handoff, where I change both package B and package A, package B to output some sort of structure that package A can use, thus breaking the explicit dependency between them, or abstracting all of the commonly needed functions into some package C that we know is really high priority. We can't retire it because all of our other packages depend on. And finally, there's testing with internal packages, which is also a little more interesting than normal testing. Typically, once again, if I own package B and it depends on package A, I can only test that B continues to perform correctly as package A changes. But with internal tests, I can actually simultaneously test both upstream and downstream dependencies back and forth, which helps me not make breaking changes in A that might affect B, even though B is the one that would typically only be able to check for the dependencies in A. So overall, I think those are just, I think, a few examples, both of how I've tended to use our packages in industry, how I've tended to use kind of the specific components that our packages can provide in kind of unique and different ways than you may have seen in packages from the real world. But in summary, like, my whole package development journey just really started from a passion for using our Markdown, building things, and a quest to just always make cleaner and better code. And before I knew it, I just ended up incidentally sort of starting to develop things. And I think should you be interested in going down the same journey, you'll be amazed, like, the things that you create almost without realizing them. And on a more practical level, if this is something that interests you, I will call out that data science tooling is an increasingly popular area with jobs. Just as a proof of concept, as I was putting together these slides in the last few days, I did a quick search on LinkedIn on data science jobs that included words like framework, tool, reproducible, and there's really a phenomenal number of results. And I think it just shows that the nexus of software engineering and data skills, which you're learning in this course, is really, really marketable and really, really important to help your analytical insights actually reach a level of trustworthiness and scale that they can be deployed out in the real world. And finally, I can share out my slides afterwards if any of this is of interest. On this last slide I have in my deck here, I've just included a number of readings and papers I found online that were really formative to my thinking about all of these topics, and really helped me fall down this rabbit hole, and would love to see others do the same. So thank you very much. That is my entire talk. Really appreciate everyone bearing with me, and very happy either to stick around for questions now, or I had my contact info on the title slide if anyone wants to reach out and talk more after.
Fabulous. Thank you very, very much. And thank you also very much for tying it back to the premise of the course and what we're trying to do here. I keep forgetting when I said everybody was as co-hosts, as participants unmuted, whether others on the call can unmute themselves or not. So if you have a question, just try unmuting and ask. Else, we can always do what we did last time. If that fails, you can type in the chat and we can read it out and then get to it. So if there are any questions, now would be a great time to discuss that. I have one on the nitty-gritty of cleaning the Markdown documents and getting rid of craft. Have you found use in any code parsers that could tell you, there's stuff here that's defined but not used, or sort of things like that? So in the linter sense of finding things to take out, or do you do that by hand?
I think it's kind of a mix of the two. Like, definitely, I think for things like package dependencies that aren't getting used, a lot of benefit in the automated tools. But I think I tend to find like a lot of the things that or at least for me personally, a lot of things more that I tend to insert or leave in my Markdown are things that could, I think, deceive automated detection because they're like often still getting knitted somewhere or like rendered somewhere. It's more just accepting that was a bad idea. I probably don't need it in my like miles long appendix and removing it. But I think definitely that's something I didn't talk about tonight, but I think huge fan of like automated tools as much, or for a lot of process improvement, because often like if you're doing it manually, you'll often in the real world like have to prioritize other things for deadlines, for efficiency. But I think the more you can automate a lot of your workflow with running tests, with running linters and stylers, definitely makes it far more likely that you'll complete all those things.
Yeah, I agree. I mean, it's as much editorial in is this content needed or can I cut it, then and then ready to be automated. I also quite like what you talked about, jumping to the other half of the course or the presentation, about the API design and the variable handoff rather than having explicit calls in there. And I don't think I've seen good write-ups on that. Do you have a reference handy by chance?
That is a really interesting question. I don't actually know
also
that
to the test pattern that you then had on the next slide. I don't think I've seen that, and that's very clever. Independently testing that the provider function exports correctly and the importer function picks it up correctly, because writing the right tests in harnesses and that is important, and that's not well discussed. But if something comes up, we can definitely put that on the public-facing guest lecturers website. So I'd love to take your links there and put the slides there if you can make them available so we can follow up.
Oh, yeah, definitely. I will email those out to you right after this. But yeah, unfortunately, I don't have a great reference for the testing bit. It was more just, I think, driven by paranoia or kind of early on in my internal exploration packages when I started moving from mere small number of other people developing to more people developing, just thinking like, how do we bring the same like rigor of sustainability internally as externally? But
no, it's good. I mean, I will admit to the fact that in the mixed degrees that I've taken till I ended up being an econometrician or what have you, I once also had a software engineering class, but that was of course under paradigms from decades ago. So, but what that left with me was this whole notion that APIs of course are contracts, and then that's a recurrent thing. I mean, others have written about that too, and that's sort of still valid. And in the notion that it is a contract, you can of course test for maintained or changed assumptions in the contract, whether it does what it's supposed to do is specified on and or aberrations thereof when the values vary. But the back and forth was that was very cleverly expressed. I don't think I'd seen that. So all in all, this was great, because I mean it squarely got it where I want this course to be. Apart of course from the cough fact that I don't teach with uses and dev tools, because I think it's also foundational to have a knowledge of the underlying commands that are driven by the wrappers in case something goes pear-shaped, then you may be better equipped to debug, why something that didn't quite work, rather than laying it all too much on the very handy tools. But yeah,
Yeah,
great presentation.
You can't beat knowing
all
the
the nice
foundations.
facilities in our studio. It's a really rich environment. It's good. Thanks.
Well, awesome. No, thank you all for having me. And honestly, love talking to students. If anyone has questions, if I can be of help to anyone, thrilled to do so.
Alton unmuted, so go ahead.
Yeah, thank you very much for the talk. It was really interesting. I was wondering what you or other people that you work with at Capital One do to prevent your work from being siloed and to encourage it seeing general use across the company.
That is honestly definitely the million-dollar problem, I think, of any corporation and just knowledge management in general. I don't think I wish I had a phenomenal solution for that, and I really don't. But I think there's always, I think, a fine line in an industry setting between figuring out what you can share freely and what does, of course, respecting any relevant confidentiality. But I think mostly the kind of the biggest and most basic and foundational thing is just saving things somewhere. I think in some ways, the pandemic and going remote's been a real asset in that regard, because a lot of things that used to just be conversations are now written down. And then after you get things written down, the kind of next step at the very highest level is just making sure they're saved somewhere. And for the more technical work, package vignettes are definitely one of my go-to places for ways to save things, because I know that will fall into the hands of the person doing the problem most similar to me the next time. But it's definitely a challenge. I so often pine for an internal analog of Twitter, because I'm always amazed just how effective that kind of latent community is at sharing knowledge. And yeah, phenomenal question. Wish I had a better answer, but in some ways, I think it's just definitely a lot of both documentation, talking to people, and kind of hoping the right wires cross. But I've definitely also stolen a lot from our community's community building efforts. And I think just the more you can get like-minded people in rooms together that are more likely to be dealing with the same types of problems, you're at least probabilistically increasing your odds that some of those right synergistic encounters will happen.
That's wonderful. Thank you very much. I actually have another question, maybe on the more technical side, but when you talk about developing, hard tools to help access data in a database, for instance, do you have a test database that you can run your code against, or do you use the dev version or the prod when you're running your unit tests?
That is a great question. I would be perfectly honest, even if I'm not proud to say it, that our database connection functions don't actually have unit tests at the moment. So that is the 100% honest answer to that question. There is actually a very interesting package called DittoDB that does create a mock data set for kind of testing functionality that relies on databases for both databases and APIs. There's this concept in testing called mocking that is very useful. However, there are downsides to that. If I have a function that both calls an API and then does something with the data, I can use mocking to effectively test the doing something with the data. It's fine by mocking what the results of the API would be. However, of course, a mocked database or mocked API is still doesn't test that nothing's fundamentally broken in that connection to that resource. So again, another amazing question. That I unfortunately do not have the answer to the exact solution.
Oh, that's really cool. I think in the past when I've had that, I just kind of save like 10 lines of code in a data frame, or sorry, 10 rows of data in the data frame just to make sure I can test things. And yeah, I don't think I've ever tested credentials either.
Yeah. It's a good question. It's not uncommon problem also. With any odd package accessing a remote resource, so API accessing functions need the host to be up and present and visible and reachable. Databases, it's the same thing. So you have that that sometimes you can't assume connectivity, or maybe you run your tests in a test run framework, GitHub Actions, Azure pipelines, any of that. So the mocking definitely comes in, but while it's imperfect, it's better than not having anything. And exactly, I mean, the short answer always is to just bifurcate. If in testing, then if else, just pick up that RDS file from a standardized project package structure, as Emily has shown. But yeah, it's hard.
And that is, as you all may have picked up, I think protecting credentials is definitely a very common theme and an ever-present top of mind thing for me. And that's definitely another thing you have to be really careful about with either code or tests that want to connect to those external resources, is not having tests that contain any secret keys or anything.
That seems to be summing it up in terms of questions. Sort of last calls. If someone has one, wave your hand, type in the chat, unmute and ask it. Otherwise, I guess we'll thank Emily profusely for giving us her time and speaking to us this evening, and we'll let everybody go into their Central Time evening again. Thanks for all of us from STAT 447. We'll make some of this material available as best as we can, the slides, some links, and yeah, this was great. And then exactly, you'll check with your legal eagles whether we can post this once taped. Definitely will not do that before I hear from you. And yeah, that was awesome. Slightly rough start, but yeah, we made great, and that was fantastic presentation. That was exactly what I hoped you'd talk. It's great. Thanks again.
Well, thank you so much for having me. And honestly, everyone, enjoy the rest of this course. It looks pretty amazing to me. So yeah, thank you all for your time, and hope everyone has a great evening.
Thanks all.